Lesson number 1, Chapter 1, Math 30-1. Here we're looking at dividing a polynomial by a binomial. So first thing we're going to try to do here is just look at what we've done way back in junior high. You learned how to divide. We're going to apply now, take the process of dividing and apply it into when we have x's and y's and all kinds of variables attached to it as well for the polynomials. So let's remind ourselves of how to use long division. So the first one we're saying 2748 divided by 13. So that's 2748 over 13. Well, in long division, what we have is, and we have to decide which one goes where. And I know a lot of people, they always struggle, okay, where do I put what where? Think of it this way. These two numbers are going rushing into the bathroom. This one gets there first. So the first number that you write gets to the bathroom first, gets to go inside, and the other one has to stand outside waiting for that one to finish. Now we're going to divide. So your process here is saying, how many times does 13 go into 27? So we want 13 going into 27. Take that on the side. Say, okay, 13 divided by 27 divided by 13 goes how many times? And we know that that's going to go 2 full times. So 2 point something that's going to be. It goes in 2 times into the 27. Well, we now need to go back and say, okay, well, how many is 2 13s? So 2 times the 13 gives us the 26. And that's the number that we're going to throw in underneath here. The next thing that we did is we subtract. 27 minus 26 leaves us with 1. And now we need to bring down the next number, which was a 4. And now you ask yourself, how many times does 13 go into 14? We repeat that process. Change the color here. So we say 14 divided by 13 gives us 1 point something. So 1 full time. So 1 goes up. I'll keep that green for you. 1 goes up. And then we bring it back here and we say, okay, 1 times the 13 gives us 13. That number goes back in and under. And we subtract again. 14 minus 13 gives us 1. Bring down the 8. And now we want to know how many times does 13 go into 18. 18 divided by 13 gives us 1 full time, point something. Going in 1 full time. And then again, 1 times 13 gives us 13. And that number we write underneath. And subtract again. 18 minus 13 gives us 5. So when we divide these, we get 211 as the quotient. So that's our quotient. With 5 as our remainder. And one of the big applications of the long division is to be able to take an improper fraction into a mixed number. We could verify this. And if we want to say, okay, does this work? Well, take your, if we're saying that, I guess we'll write it this way, 2748 divided by 13 is equal to 211 remainder 5. Well, to check, to verify, we say 211 multiplied by the 13 plus the remainder of 5. If we go 211 times 13 and then add 5, oh yeah, we get 2748. So that's a verification of it. Let's do the next one. We'll do it a lot quicker. I explained all of those steps because those steps are what we are going to need to apply then into the polynomials. Let's go through the next one real quick here. Again, the 4212 is running faster. It gets in there first, and the second number was 27. Go through again. We're looking at 42, and we're looking at the 27. So 42 divided by 27 gives us a 1. 1 times 27, 27, and we subtract. Leaves us with 15. Bring down the 1. So now we're saying, how many times does 127 go into 151? So closest to 5 times. 5 goes up. And then we're doing 5 times 27, which gives us 135. 5 goes underneath. Subtract again. And in that subtracting, we get 16. Bring down the 2. How many times does 27 go into 162? Oh, that goes in 6 times. 6 times 27, that is 162. Gives us a remainder of 0. So the next question there is, right at the bottom there. Oh, right there it is. What does a remainder of 0 mean? Well, a remainder of 0 is telling you that it divided evenly. Or another way of saying it is, 27 is a factor. 27 is a factor of 4212. I'd like you to take a moment, try to pause here and try to apply this yourself to see, challenge yourself, can you do this in the same way? I'll help set this up here, but I want you to actually try to see if you can figure it out yourself before you look at this. Learning it yourself, you'll remember much more than if you just copy what I'm putting down. Okay, so that's where we would start. So I encourage you to pause and try it out. All right, let's look at this here then. I'll walk you through. As we're going through these, what we want to do is we want to take your first number, 3x squared. So that first term. And we want to look at the first term of your binomial. We're going to divide those. Or I'm going to take it on the side, and I'm going to do it over here. 3x squared divided by x. Exactly like I did with the numbers in that first example. 3x squared divided by x, that leaves us with 3x. That's what I'm going to bring up on top, 3x. I like to keep my x's and x squareds and everything lined up. So I'm going to put the 3x here, right here, above the 4x. Now we're going to take it and do exactly like we did. Multiply the 3x multiplied by the x minus 2. And expand that. That leaves us with 3x squared minus 6x. This is a number that we're going to write right underneath, just like we did with the numbers. And we're subtracting. That was the next step that you did. We're subtracting this whole thing. Some people really struggle with subtracting negatives. So I encourage you to do this. When you put subtracting there, change all the signs. So subtract, that becomes negative and positive. So you're going to subtract this one, add that one. So I'd suggest change all the signs for subtracting. Change the signs and then add. 3x squared and negative 3x squared, those cancel off. If they don't cancel off, you've done something wrong. You need to stop. You need to start that again. That first term always has to cancel off. And now we go negative 4x and a positive 6x. Those together are going to give you a 2x. Bring down the plus 5. And from here, we're going to do the exact same thing. Now we're going to look at the 2x, and we're going to look at the x. So 2x divided by x gives us 2. Write that up over on top. That was a positive 2. So I'm going to put a positive 2 up here. Again, multiply 2 times the x minus 2. So we're multiplying the 2 times the x minus 2 there. Expand that to x minus 4. That's the number that we're going to bring in underneath. We're subtracting, so I suggest you change all the signs and add them. Much safer. 2x and negative 2x, those cancel off. They better cancel off. A 5 and a 4, both positive. That leaves me with a 9. So the answer now is, when we divided 3x squared minus 4x plus 5, divided by, put brackets around these, the x minus 2, we got left with the quotient, which was 3x plus 2, got it from up here, with a remainder of 9. And I got that from down here. All right, speeding up a little bit more, trying this next one here. 2x cubed minus x squared minus 2x plus 1 divided by x plus 1. Step number 1. 2x cubed divided by x. These are with 2x squared. 2x squared. Multiply 2x squared times x plus 1. Distribute that in. 2x cubed plus 2x squared. Bring that back in and underneath. 2x cubed plus 2x squared. And now, this is the step that lots of people forget. You're subtracting. Change the signs. Minus, minus. And now we can just add them. 2x cubed and a negative 2x cubed always has to cancel off. Hiya, gone. Negative x squared, negative 2x squared. That's going to give us a negative 3x squared. Bring down the next term. Repeat our process. Looking at the first terms, negative 3x squared divided by the x gives us negative 3x. That's what we're going to write here. It's negative. So negative 3x. Multiply negative 3x multiplied by the x plus 1. As we distribute that, we get left with negative 3x squared minus 3x. And that's what we're going to write underneath. Negative 3x squared minus 3x. And we're subtracting, so we change all the signs. Hiya, hiya. Negative 2x and a positive 3x, that leaves us with an x. We bring down plus 1. Now we're looking again at And x divided by the x. X divided by x gives us 1. Positive 1, so plus 1. And then we multiply 1 times the x plus 1. Leaves us with x plus 1. When we subtract that, remainder of 0. We're saying in this case that 2x cubed minus x squared minus 2x plus 1. When we divide that by x plus 1, our answer is 2x squared minus 3x plus 1. No remainder. It divided evenly. Also known as a factor. Keep that in mind. So long division can be used to divide a polynomial by a binomial. Since division by 0 is not possible, assume that the divisor is never 0. So we need to remember what the names of these things are. If we divide x squared plus 2x plus 5, this is called the dividend. And the x minus 1 is called the divisor. I already told you about the quotient and the remainder. So we'll look at those again as we go through. So the process again of dividing, and you've got this in your book there on page 3. Okay, the first thing is we divide the x squared by the x, like I said. This x squared by that x. That left us with x. Then we multiply. We expand that. Okay, the x back times the x minus 1. So that part of this part of the quotient and divided by, multiplied by the divisor. Then we write it underneath and we subtract and bring down the next number. Divide the 3x by the x and multiply and then subtract. So the quotient now, quotient is the number up here, x plus the 3. The remainder is the 8. The dividend is the original polynomial that we started with, and the divisor is a number that we put outside to divide by. Key little thing. Make sure that when you're dividing, we always write the polynomial and the binomial in descending order. X squared, then x. So if it's x cubed, then x squared, then x, then the constant. And I also let you know right now, if you're missing some part of it, you need to put in, maybe you're missing an x, you have to put 0x as a placeholder. All right, let's try this one out now. Good idea for you to try to get ahead of me here and see if you can do it. Well, first thing you look at it and say, okay, well, that's not in the right order. I need to adjust that. So this plus 3x, that's got to go up over here. This has got to go back over there. So we're going to rewrite that. So 2x cubed minus 2x plus 3x. Oops. Let's redo that. Let's actually do it in the correct order. 2x cubed plus 3x squared minus 2x plus 5. There we go. We're going to divide that by x minus 1. Looking at the first. So 2x cubed divided by x gives me 2x squared. Write it above the x squareds, and then we multiply 2x squared multiplied by the divisor, which gives us 2x cubed minus 2x squared. Write that underneath. 2x cubed minus 2x squared. Always make sure you're lining up the cubes and the quadratics there. And now we subtract. So for subtracting, change the signs. Don't forget to do that. That is a key step that people always mess up. And those ones always have to yeah. Then we got a positive 3x squared and a positive 2x squared. Going to leave us with 5x squared. Bring down the next term. Same process. Divide. 5x squared divided by the x. The x is from the divisor over here. Gives us 5x. And multiply. Multiply by the whole divisor. The whole divisor. 5x squared minus 5x. Bring that underneath. 5x squared minus 5x. For subtracting, so change both signs. And now we can just add. Those negative 2x and a positive 5x leaves us with a positive 3x. Bring down your next term. Divide. 3x divided by the x leaves us with 3. Multiply by the whole divisor now. Write it underneath. I'm hoping that some of you can do it without having to write all the stuff on the side now. You should be able to cut out some steps for yourself. Speed it up. Oh, got to change the signs. 5 plus the 3 gives us the 8. You can see how it's quick and easy to forget to change those signs. We now have, I forgot to write these up here. Yay. This was plus 5x and plus 3. That one came from here. That one came from here. That one came from here. And they were all positive. So when we divide those, we got 2x squared plus 5x plus 3 with a remainder of 8. And I'll remind you how to verify. So in order to verify, we just multiply them up again. So you've got your divisor multiplied by the quotient plus the remainder. That's really what we've got sitting there. And just multiplying them up. You can see that in your book there, the way that they distribute. And now, since the original polynomial is what you come up with, your answer had to be correct. There's your way to check. And good to read that question or that little paragraph yourself, so you can see what it's telling you. Because we've got a question here that you're going to try. What is the degree of the quotient polynomial when this is divided by that? And your options are 2, 3, 4, and 5. I'm going to have you log in with your Google password to bit.ly, so bit.ly /NCHW and a small j. Sign on there now, and then you can answer this question. There is one more question coming on in the notes as well. So I suggest pause this presentation, move on, log in, and then come back. When is it not necessary to use long division to divide a polynomial by a binomial? I want you to write something there, pause again here, and write something down for yourself. And we'll discuss that in class there. When a polynomial is divided by a binomial, the division statement, also known as division algorithm, relates the original polynomial okay, to the divisor, quotient, remainder. Looks like this. Your original polynomial, which is your answer, your starting place, your polynomial, is equal to the divisor, we'll call D, multiplied by the quotient plus the remainder. Oh, that was the check, the verification that we just did. I'm also going to show you another one that they don't show in this book here, but I think is quite powerful as well to do. When we first talked, right at the very beginning, the first question we said 2748 divided by 13 was equal to 211 with a remainder of 5. This we're saying is our original polynomial. This one here is our divisor. This here is our quotient, and this here is our remainder. So we're going to just put that together. We're going to say our polynomial, with x as the variable, divided by the divisor, is equal to the quotient, with x as the variable, plus the remainder. And sometimes that remainder could have an x in there. For the ones that you're going to see, probably not. But that is a secondary division statement. So like I had said, if any spot is missing, any powers are missing, you've got to fill them in with a 0. You'll see that in the next example. Actually, sorry, got to go through that as well. Pause, fill that in something there. We can discuss that kind of a question again tomorrow. All right, let's try this one out. And I'd like you again to try to get ahead and go yourself. But remember what we just talked about. 3x to the 4 minus x cubed. Oh, there's no x squared. Plus 0x squared plus 3x minus 20 divided by x plus 2. Again, pause it, try it out, see if you can get this one yourself. Okay, so 3x to the 4 divided by x leaves us 3x cubed. 3x cubed, write it above the cubes. Multiply it back together. 3x cubed multiplied by x plus 2. And so we've got 3x, oops, I should, gives us 3x to the 4 plus 6x cubed. So we've got 3x to the 4 plus 6x cubed and subtract. So change both signs and add, changing the signs. And that gives us, those ones are gone. I'm not going to do that this time. That goes down to 0. Those ones now subtract, that gives us negative 7x because they're both negatives. And now we need to bring down the plus 0x squared. Repeat the process. Negative 7x cubed divided by the x gives us negative 7x squared. Negative 7x squared multiplied by x plus 2 gives us negative 7x cubed minus 14x squared. Write that underneath. Change both signs and add. Leaves us with positive 14x squared, bring down plus 3x. $14x squared, oh, I forgot to write this up here again, minus 7x squared. 14x squared divided by x gives us 14x. That's positive, so positive 14x up there. And expand. 14x multiplied by x plus 2 gives us 14x squared plus 28x. Write that underneath. Change the signs and add. Gives us a negative 25x. Bring down the minus 20. And last one to repeat on here is negative 25x divided by x gives us negative 25. Negative 25 goes up on the quotient and expand. Negative 25 multiplied by x plus 2 gives us negative 25x minus 50. And change the signs and add. Leaves us with a remainder of 30. So I know you're all extremely excited about this. This is just a newfound skill. But wait, there's more. If you call in the next 30 minutes. There's a lot. This has taken a long time to do one question. Mathematicians say, I don't want to waste time on redundancy. Things that are repeated over and over again. Don't copy what I'm doing now down, because we're going to do some examples, but just follow along and see the logic of what we're doing. Look at all these things. I'll use green here. Actually, I'll highlight it in green. We're going to look at everything that we write over and over and over again. Okay. Well, first of all, there's x's involved. I know there's x's involved. There was an x here. We always had an x sitting in front there. We have x here, x here, x here, x here. No x on that one, but I knew that. Okay, look at all these x's. And if you notice, all the x's are constantly going down. So if I started at x to the 4, I know the next one's x to the 3. I had a placeholder, so even if I got rid of all those x's, including their exponent, you should be able to tell me, oh, that's 3x to the 4 because 20 had no x, that had a 1, 3 had a 1x, the 0 had an x squared, then a negative, the negative 1 had a exponent of 3, then an exponent of 4. So all those x's are really pointless. You know what we're going to do with them? We're just going to we're going to get rid of them. We don't need them. Whoops, lost the 7. So I'm going to get rid of all of these x's because I know those x's go in there. I could go through and fill them in. Every single time, if you notice as well, when I go through, the 3 and the 3 are going to be the same. The 7 and the 7 are the same. 14 and the 14 are the same. 25 and the 25 are the same. Well, why keep writing it again and again and again? So, I'm just going to get rid of each one of those. Because I know I'm just writing the same thing over and over and over again. And then, you know what? We kept doing change the signs and add, change the signs and add, change the signs and add. We did that 3 times. I don't want to do it 3 times. I'm going to do it once. And the place I'm going to do it once is right up here. I'm going to change that into a -2. And by doing that, it's going to change all the signs along. You'll see. This, what's left over, oh, just a minute. We got some more of that repeat. That 0 was brought down, the 3 was brought down, the -20 was brought down. Let's get rid of those. I'm not going to just keep writing the same thing I'm bringing down. I know that. What we have left there right now is called synthetic division, not long division. It looks crazy from the explanation I just did, but it's a heck of a lot faster. You do have to know how to do both. Let's look at what synthetic division is. Quickly, I'll just whip through their explanation. But it's more important that I show you mine. Okay. So if we're dividing by x minus 2, I said change that sign. Use the additive inverse, the positive 2. So our a value is going to be 2. First thing we're going to do is we're just going to look at all of our coefficients from our polynomial, and we're just going to look at that a value. Use the green there. A value comes down, and then all of our coefficients pop down and in. Drop down the first one because it's always going to be the same value. If you notice on all those examples we've done, the leading coefficient was always the same. And now we multiply. 2 times the 5 gives me to 10. Write it underneath, and because we already changed the signs, we can just add. We don't have to subtract. 17. 2 times the 17 now gives me 34. Write it underneath the next one. And add. Negative 4 times the 34 gives me 30. This last one here is your remainder. And I know that it went from x squared down to 1 less degree. So this is going to be a 5x plus a 17 with a remainder of 30. Again, going back to that bit.ly site, in the same site, you're answering question number 2 at this point now. Okay. What's the value of a in this one? And last question, we're just going to do a synthetic division of this. We're not going to waste our time with long division if it doesn't say use long division. So first of all, we have to check, do we have all of the terms? Yes, we do. So negative 3, 2, 3, negative 4, and a 5. It's plus 2 here. We're changing the sign and writing negative 2 because we can just change it once. Drop your first one down. 3. Negative 3. Now multiply. Negative 2 times negative 3 gives us positive 6. And add. 2 plus 6 gives me 8. Negative 2 times the 8 gives me negative 16. Add 3 plus the negative 16, negative 13. Now negative 2 times the negative 13. Multiply, gives me 26. And add 22. 22 times the negative 2 gives me negative 44. And add negative 39. Box that last one in because that's your remainder. And now we write down what this says. This says negative 3x. It was x to the 4, so it's now x to the 3. Plus 8x to the 2. It just keeps going down by 1 degree. X to the 1 plus 22 with a remainder of negative 39. That's what it's saying. So our division statement is our polynomial, the original thing they gave us. Negative 3x to the 4 plus 2x cubed plus 3x squared minus 4x plus 5 is equal to divisor x plus 2, bracket that off, times the quotient, negative, that's right here, negative 3x cubed plus 8x squared minus 13x plus 22, plus the remainder. The remainder is negative, so negative 39. Polynomial, divisor, quotient, remainder. Try and take it a little bit further, thinking further. How can you do that if we've got this sitting in front? But notice, just with the numbers we got here, see what you can do with that. It's good to try that one out. And then last 2 questions, and these are the questions, kind of things that we're going to be starting with next class. So be prepared with some answers. What strategies could you use, and how is long division related to synthetic? I encourage you to try out some of the Math Excel questions, and then we'll see you in class.